this recording, we will be going over some basics of our basics of R. So first, let's go to our first project. Again, if you remember, we were left off with my second script. It was opened already. I was working with that one. I deleted the ABC stuff, but we're gonna define these again. So first, we will be talking about objects. Okay, objects. So first, I will define letters X and Y. Let's say, okay, let me put it that way. Suppose we have a rectangle. Let me start writing some comments, okay? These comments will not be executed. So how to start comments? You can add hashtag. When you add hashtag, this will not be part of the codes. This is just comments for you. So let's find the area of a rectangle, okay? Where X is the length, or L is 10, and W width is a small letter is, I don't know, 8. Okay, so the first line is just a comment. So first we have to define two objects. Okay, the first object is going to be L, so L, and I'm going to assign a value to this L. By the way, if you start from third line forward, doesn't matter, okay, any line, but the order of executing codes is important, does matter. Okay, so let's say L is, I'm going to assign a value to L. So less than and hyphen, these two together, that means that you are assigning a value to the variable, in this case L. This is 10. Enter, I'm going to assign a value. So this is a very important convention now. To assign value to a variable, we either use less than and hyphen, or we use equal. We can use equal, but we recommend against using the equal sign to avoid confusion, because equal, we use it in different contexts and different situations. So to assign values to any variable, use this. So now R knows that L has a value of 10, W has a value of 8. I have not run any code yet. So for example, if you go to console, let me just clear this. Okay, if you go to console and you type L, enter, what happens? We got an error because L is not defined yet. Okay, we defined it, but we did not run it yet. Okay, we did not store it. We did not store the value we defined. This is the best way to say it. We define L, but we did not store it. So R here, say, what is L? What is this object? So how to store this? You store it when you run it. So I'm going to run this one. Look what happens when you run this. We got this L stored. So it's defined successfully, and it's stored successfully. So now if I type L here, it tells me, oh, L is 10. By the way, once you run the L here, you immediately see it already in the console. So in the console, let's do the W. Look, run W, and watch what happens. I'm running now line by line. What if you'd like to run everything? If you'd like to run all of the code, you can just select everything and run. I don't want to do this now. So I am now at line 3. So run this one and see what's happening on the console. Look, U equals 8. So it's running the code now. Now if you type W here, look at the workspace, the environment. It's saved already. So type W in the console. Now it says, oh, it's 8. Okay. So we ask R to show the value stored by typing only W. Or you can use another function called print. Print, parentheses, look at what we got, a list of options. Print W. So we have two options, maybe we have more, we will be talking about these. So R shows you W, even if you use a print W or you use just W. Okay, so this is object. These, we have two objects stored in R, and these are variables. But the objects, the variables are objects. Do we have any other objects? Yes, we have functions as objects. Okay, so we have defined two objects. Let's define the third object, which is a calculated object. Area, you can call it area. Area is going to be L times W. Run area. Look at the calculated area, it's 80. If you'd like to see it, again, if you would like to see print area, you can type print here, or you can type it in the console. What is the difference? The difference is you cannot save the console. You can save the script. So anything you would like to save, any code, serious code, you have to put it here. Print area, it's 80. Okay. So now we have defined three objects, and all of them are variables. Okay. As we define objects in the console, if you define object in the console or in the script, we are changing the workspace. So we see all of the variables saved in your workspace. And what if I would like to see everything I have saved? Suppose I have a list of values here. So what to do? Use list, ls function, ls parentheses. This is another function. Just enter. It tells you everything is saved in your environment. Okay. If you, for example, bring another letter, let's say D. D, this object is not found because we did not define this one, right? Once you define your variables, the data analysis process can usually be described as a series of functions applied to this data. R, let's know this, R includes several predefined functions, and most of the analysis pipelines we construct make extensive use of these. We already, by the way, used 3 functions at least now. In the previous videos recordings, we used a function called install packages. This is a function. We used library. This is a function, a pre-built function in R. We used ls. This is a pre-built function in R, right? So there are so many pre-built functions, and more can be added through different packages. And these functions, they do not appear in the workspace because you did not define them, you did not use them, but they're available. Once you use them, they're available. And again, in general, we need to use parentheses to evaluate a function. If you type, for example, ls, look at this. We got problem. It tells you, oh, ls is a function, etc. We cannot use just ls parentheses. It's empty. Nothing is inside because ls has a specific job. Now the question is, now ls is evaluated and we can see the objects in the workspace. But most of the functions, they require to have arguments. The arguments is the thing, is the object that is going to be inside the parentheses. For example, let's work on the console a little bit. If you type log is logarithmic function, but log immediately it gives me parentheses. It says argument x is missing, so that means we should have something inside the log. So log of 10, it's 2.3. So we have to assign an object to the argument of the function log, okay? And how to know the functions and how to know the functions contains arguments or no, you can actually, either you can say help, use help function, log. Once you type this, the right hand side goes to the help and give you example of our description of the log, how the log works. And it says, for example, log, we can use it in these ways. And these are the arguments, description about the arguments. We have 2 arguments for the log, x and base. And look at them, x comma base. For example, but by the way, either you can use help or question mark log. It's going to take you to the help. Now let's use log of 10 comma, this is my x, base equals exponential 1, or let's say 1, infinity, inf infinity, 10, 1. So we have 2 arguments for the log. The first argument is the one that represents x, the second one is the base. If you do not include the word base, if you did not give it the name, if you did not assign the name, R assume you are entering arguments in the order shown in the help. So by not using the names, R assumes the arguments are x followed by the base. So the order is important. However, if you like to switch the order, then you have to specify. So for example, this is 100. So the first one is x, the second one is the base. Let's check this one, correct. But if you switch them, so R is going to understand that the first number is x, the second one is base. But if you'd like to use the first one as a base, you have to specify this. Oh, it's a base. Excuse me. And if you notice in the arguments, we never used less than hyphen. We use equal sign. We cannot use less than equal. We use it only when we would like to define variable or object. Okay. Let's look at other functions. Let me find another function called data. This is a pre-built function, and this will give you the data sets are included for users to practice and to test the functions. You can see all of the available data sets by typing data. If you run this one, again, I have to run it. If I type it on the script, I have to run it. If I just throw it on the console, there is no need to run because the console is the one that runs or executes the code. So when I run the data, I see all of the data sets available in the packages that I have in my R. We have air passengers, we have BJ sales. This is kind of a descriptions. If you'd like to know more, you can just type, let's say CO2. Is it CO capital? I don't know. Yes. CO2, this is the CO2. We have these columns in CO2. If you'd like to view it as a table on the top, if you'd like to view it, you can use a view function. capital V, CO2. So look at CO2, it's already here, it's viewed. Let me go back to my script. I would like to clean again, Control L. Other like pre-built objects are the mathematical quantities like pi, small pi, or infinity, INF, infinity. These are pre-built constant functions that we know. So we have used letters L and W as variable names, but variable names can be almost anything. Some basic rule in R that the variable names have to start with a letter, cannot contain spaces, and should not be variables that are predefined in R. So you can't say, you can't define library less than or equal, or assign a variable library to be 1. You cannot use this because this is going to be confusing. Okay, avoid using names of the variables already. You have pre-built variables, or variables that are use it already. Don't use like mean. This is a variable already, so don't use these names. Okay, it's assigned here, but this is wrong. So to remove these objects, we're going to use 3 functions, or 2 functions. rm is remove, list, c, library, comma, mean. So I have removed these 2 objects. So this is we talked about objects here, we talked about variables and the pre-built functions, and these values remain in the workspace until you end your session or erase them with the function remove. So you can remove what? You can remove everything by typing list equals ls. Remove the list of all of the objects. Do you remember ls? So if you type this, everything will be removed. If you want to clear this, you can clear it by Control L. Now we have everything is cleared. But if you'd like to keep all of these, run all of these, and if you close it, if you close this one, what's going to happen? It's going to, you will not lose anything because everything is saved, right? So everything is saved here. So if you close it, you can do so, and you can open it. Once you open it, you will be going to the place that you were left off. So we said values remain in the workspace until you end your session or erase them with the function remove, as we did before. Remove the list of ls, all of them. Sometimes you'd like to use the workspace later. So I actually do not recommend saving the workspace right now, but you can give it another name if you'd like to save only the workspace. So we know how to save the script, right? So to save the workspace, everything is loaded here. So what we can do, we can just go to session. For example, let's do this before we're doing anything. Let's close this. Let's open the project again. Everything we left at is there, but the workspace was not saved, so I have to run all of these again. Okay, so as I said, we are against saving the workspace at the same time with the project, so you can save it in another place, another file, then you can load it again. So what you can do is going to the session, and you can save workspace. Let's call it first workspace. So if you close your R now, you can see first workspace.r data is saved. But again, now I would like to start my project, to continue working on my project. So the first place I go to is my first project, rproj. So click on this one, and suppose that you have a big data here, big code lines, and you don't want to run this again. You would like to run to load the workspace. So where to go? Go to session, load workspace. Then the file is my first workspace. Then we have it here. So look at what happens in the console. The console builds something. It uses a function called load. It's a pre-built function, load, double quotations, and the destination of your file, okay, is the path of your file. So you can do this manually, or you can use the session. So this is everything about the basics of the code. Then we'll be having another part talking about other issues.